Okay, so let's start doing these limiting reactant problems. No pictures here. We're just starting with the balanced chemical equation and the amount of moles of each reactant that we are given. So question 46 says if we begin with 1.8 moles of titanium and 3.2 moles of chlorine, what is the limiting reactant and the theoretical yield? And how much product, or basically what we're going to do is figure out how much product can be made from each reactant. So I am doing basically a stoichiometry problem that we did last chapter just twice. So I am starting with 1.8 moles of titanium, and the question that I'm asking is how much titanium 4 chloride can I make? And according to the balanced chemical equation, right, 1 mole of titanium will produce 1 mole of titanium 4 chloride. So therefore, I could make 1.8 moles of titanium 4 chloride. What if I start with 3.2 moles of chlorine? According to the balanced chemical equation, 2 moles of chlorine will be required to produce 1 mole of TiCl4. So in my calculator or in my head, 3.2 times 1 divided by 2 is 1.6 moles of TiCl4. So now I have 2 answers to this question. Only one of them is right. And remember with the pancake example, which one made the least amount of product? Well, it looks like this is the correct answer, because this is telling me that once I make 1.6 moles of TiCl4, titanium 4 chloride, the reaction's going to stop. Why? Because all of the chlorine will be used. So we have to write a little statement here that sort of sums this up, because the work sometimes doesn't speak for itself. We need to explain to the reader what exactly has happened here. And so since the chlorine, Cl2, will produce the least amount of product, it must have run out first, and thus was the limiting reactant. Only 1.6 moles of TiCl4, titanium 4 chloride, can be made before the reaction stops and the limiting reactant, the chlorine, runs out. So let's review what we did here again. I read the problem. How did I know this was a limiting reactant problem? Well, it asked us what was the limiting reactant and the theoretical yield, but also it gave me 2 reactants. So what did I do? I took each of those 2 reactants and I solved the problem. I said how much titanium 4 chloride could be made, and then the lower number was the correct answer, and that was the maximum amount of titanium 4 chloride that I could make. Now let's look at the next one, question 47. And if you feel like you want to try this one on your own, pause the video, right? Then try it on your own and then restart the video, and you can scan ahead to find the answer. And the same thing with 48. Okay, so we have 2 more practice problems of these. I'm going to go through them, but if you feel confident that you know how to do these problems, you can go ahead, pause the video, do these on your own, and then come back and check your work. So question 47 says if you begin with 0.552 moles of aluminum and 0.887 moles of chlorine, what's the limiting reactant and theoretical yield of aluminum chloride in moles? This is a synthesis reaction here. The aluminum loses electrons, the aluminum is oxidized, the chlorine gains electrons, right? The chlorine is reduced here. It makes an ionic compound because we know aluminum is a metal and chlorine is a nonmetal. So how do I do these problems? I do the stoichiometry problem with both reactants. So I start with 0.552 moles of aluminum, and I'm going to do a stoichiometry problem to find out how much aluminum chloride can be made, right? I look at the coefficients here. 2 moles of aluminum will produce 2 moles of aluminum chloride, and so therefore I can make 0.552 moles of AlCl3 if I use up all my aluminum. Now what about if I use up all my chlorine? 0.887 moles of chlorine. According to the balanced chemical equation, right, 3 moles of chlorine will be used to make 2 moles of aluminum chloride. Right? And this is going to be 0.591 moles of AlCl3, right? Of course, significant figures here always count, right? The coefficients don't count. Okay, so now I have 2 answers. Which one is correct? Which one is the right answer? So the right answer is always the lowest one. So this is the one that is lower. This will tell me that after 0.552 moles of aluminum chloride is made, the reaction will stop because the aluminum will run out. So I can't make 0.591 moles of aluminum chloride because there would be no more aluminum left to do that. Okay, so we always go with the smallest. Like, why did I put a box around this? Because that number is the smallest compared with the 0.591 number. So now let's write our concluding statement here. So since the 0.552 moles of aluminum will produce the least amount of product, it must have run out first, and thus was the limiting reactant, right? Only 0.552 moles of aluminum chloride can be produced before the reaction stops and the aluminum runs out. Okay, and we have one final question for you to try. Again, if you haven't tried any of these on your own, maybe this is the one that you want to pause the recording and give this one a try. This should be number 48, I believe. If you begin with 4.8 moles of sodium and 2.6 moles of fluorine, what is the limiting reactant and the theoretical yield of sodium fluoride in moles? Okay, so these are the 2 reactants that I'm starting with. Which one runs out first? That's what I have to figure out. So I just start with 4.8 moles of sodium, and I look at the coefficients from the balanced chemical equation. 2 moles of sodium will be used to produce 2 moles of sodium fluoride. So of course that will be 4.8 moles of sodium fluoride can be made. And then if I start with 2.6 moles of fluorine, according to the balanced chemical equation, 1 mole of fluorine gas will make 2 moles of sodium fluoride, and that would be 5.2. Okay, so which one made the least amount of product? Well, it was this one, right? That top one right there. Now, in these examples, it's been the top one, the first one in both times. That isn't necessarily going to be the case, right? I could have just written the question differently. So we're not going to think of that as a pattern. That's important. The other one that I want to point out to you is a lot of students want to say it's the lower number of these, right? But you have to look at the coefficients from the balanced chemical equation, because was fluorine the limiting reactant? No, it wasn't. The sodium was the limiting reactant. So we can't look at just the numbers. We do actually have to do this process, right? So since 4.8 moles of sodium will produce the least amount of product. It must have run out first, and the sodium, was the limiting reactant, right? It must be one of the two reactants. Only 4.8 moles of sodium fluoride can be made before the reaction stops and the sodium runs out. So we do need to do this process in order to figure out the two questions that are being asked of me: which reactant is the limiting reactant, and how much product, which we call the theoretical yield, how much product can be made.